so niggas just like the Dean. I feel like Michael Jackson. I could do the Calabash. We back at I put the virgin. Okay, welcome back, you guys. Let me make sure I have my other. Okay, perfect. So yes, welcome back. So it is Friday. We're coming to the end of week 2. Today we're really just going to knock out. Let's take a look at the exam topics really quick so we can see what else we have left. I don't know why this keeps popping up, like restore last version. What does that mean? Okay, so yeah, we did all week 1. Week 2, we have talked about Ether channel. That was yesterday. We already talked about spanning tree. So now we can compare Cisco wireless architectures in AP mode. So we're just comparing them. We can describe physical infrastructure connections of a wireless LAN. We can describe, okay, so basically we're all going to talk about 2.6 to 2.9, which is all about wireless, right? A wireless LAN. And we're just describing, right? We're just comparing and describing. So there's going to be a lot about terms and definitions. So definitely make sure that you have your notebook, your pencil, pen, and you're taking notes. As far as configuring these components, let's see, using the GUI, we will do that tomorrow. That'll be our lab for tomorrow. We'll know exactly what entails to do it, but as far as getting dirty into Cisco Packet Tracer, let's save that for tomorrow. Let's just make that a lab day / study day, and we'll just have the weekend to study. Basically we're studying just, week 2 and week 1, you want to compound your knowledge. So Monday starts, we'll start off knowing IP connectivity, right? Week 3 is right here, which is worth 25% of the exam. So we'll start talking about layer 3 of the OSI model. Okay. All right. So moving along, since we already know what we have going on, we're going to wrap up the last week of week 2, access the network. And let's see. Okay, cool. So we just have to right here. Bingo. Now, yesterday, let me go back here. Yesterday, we talked about Ether channel. Okay, let me just pull this up really quick. Actually, I should have pulled up the visual. The visual's better. This PowerPoint one. Okay, so Ether channel, right? Layer 2, LACP to be exact. That's really what Cisco wants you to at least be able to configure and verify as LACP. Go figure, not their own. But anyway, Ether channel, right? The same thing with STP, provides redundancy, but also it provides bandwidth, more bandwidth. As you can see, 4 gigabit links could actually share 1 gigabit link by being bundled together. And they also provide more uptime, right? So like I said, you can bundle up to 8 links instead of them. Obviously, they will be physical, links, 8 links, but logically, we can bundle them together, okay? And logically, we bundle them together. They can share bandwidth, and they provide that redundancy, okay? And there are 3 modes to Ether channel. We have a Cisco proprietary, we have a open standard, and just on, okay? We kind of configured some of these, but as far as LACP, which you really need to understand for the exam, the modes are either passive or active, okay? And that's just, will it form an Ether channel? Will it bundle together to form this channel group so you can utilize as resources? You can share resources, right? And then of course, Cisco proprietary, desirable or auto. And again, like I said, it's just like DTP. It's just like dynamic trucking protocol. So, it's just bundles 8 links. So it's still trying to, each side is going to try to form, kind of come to an agreement to form a link. What type of link will that be? Will it be standalone or will it be a ether channel, a bundle? Okay. So that was pretty easy to do that. As far as configuring, this is really all you need to know. Is you go into the interface and you actually add that interface to a group. And with that group, this is the command you're going to use, channel-group1, or name it whatever you want. But obviously, we're going to start off as 1 because it's our first group. And then the mode. What mode do we want to use? LACP or the port aggregation? And you should know which terms deal with what. Active, on, desirable, auto, what do you have? And you're going to do that to every interface. Or you're going to actually do interface range and do a range between 1 and 2. But it's up to you how you want to do that. Once you put your interfaces into a group, then you have to create an interface of the group, interface port channel 1, because I made group 1. So might as well do channel 1. And I'm just going to trunk it. We don't have to use this encap.1q because we work on newer switches. So we can just do switch port mode trunk. And then you're done. Obviously, you do want to add a VLAN, but as far as just configuring port channel, you're just adding the interfaces into a channel group. And then that channel group, you're going to create an interface for it and trunk it. And of course, you would like to allow any traffic, but we're going to trunk it. And then we're going to do some show commands. This is just one command, and I gave you guys a cheat sheet of different show commands. So, make sure you know those. But that was really it with Ether channel, right? Pretty straightforward. Okay, you just have to do some labbing to ensure that you get the configurations in your head, or just flashcard it out. Really, I would suggest you flashcard it out. But yeah, so now we are on wireless architectures. So let's go into that. 2.6, compare Cisco wireless architectures and AP modes. Okay, so wireless architectures, we have autonomous AP architecture, cloud-based AP architecture, and lightweight AP architectures. Okay, let's come down here and talk about our self-contained devices. All right, our self-contained architecture. Let me try to blow that up a little bit here. Okay, hopefully you guys can see that just fine. All right, so autonomous AP architecture. Now we know AP is just an access point. That's all it stands for. So with our access point being self-contained, that's all autonomous means is self-contained. It can have both wireless and wired capabilities. So as you can see here, it can transmit data through radio frequencies or actual Ethernet cables, right? Or fiber optics, depending on what you're using. Okay, now, since it is self-contained, that means it has some type of hardware that you can, bridge and, you can talk to via your SSIDs. And we know what SSIDs mean. It's just the name of the network. So you'll have some type of bridge with this autonomous AP to where users can connect to it. Now, it can be managed by a controller or it can be managed individually, right? Like some individual, somebody on the team can manage it, or you can have a controller, you can set up automation, and it can be managed, right? And each AP must be configured with this management IP address, so it can be remotely accessed, using like Telnet, SSH, or a GUI, which we'll get into later on, well, probably tomorrow. So yeah, so this management IP address that you see right here, this AP is going to have one. And again, it's just for us to be able to get in remotely. And as we move forward, you'll see that not only these wireless devices, but also routers will have a management IP address so we can access it remotely, right? Through SSH. We can do Telnet, but Telnet, like I said, is not, it's not secure. So SSH is the best, or you can do a web GUI interface, which is much easier because you just click save and click go and click all these other things instead of going through a command line. Okay, so just know that autonomous AP is exactly what its name means. It is just a self-contained device that you can use for both wireless and wired capabilities. So it can do both at the same time. So that's really all it is. And you can have multiple of these APs in your network. And as you can see in this diagram, there are 4 of these and how they're connected. And like I said, they're access points. So of course, they're going to be at the bottom of the flow because these are where our hosts, our end devices will connect to. Okay, and then it'll go up to an access layer up in our network to where our switches can now start forwarding and switching the traffic. And then of course we have our distribution layer and our core layer, right? 3-tier architecture. So kind of see how that goes. Moving along, we have our cloud-based architecture. Now, this is an alternative. Let me try to pull this up here. Okay, so if you don't want autonomous, you definitely can use an alternative, which is cloud-based AP architecture, where the access point management functions is kind of like it's pushed to the company, to the enterprise via the internet, via the cloud. So anytime somebody say, oh, cloud this, cloud that, which we already talked about in our previous lesson, which, you know, infrastructure as a service or software as a service, platform as a service, right? Those things are just saying that, hey, they are all managed on the internet. They're managed on someone else's server, someone else's computer, and we are using those resources, regardless of what those resources may be, whether it be just their infrastructure or maybe their whole platform, right? So anytime you see cloud-based AP architecture, that means that the network is managed over the internet, okay? So we have this cloud managed access point that, you know, we're going to manage via some type of, you know, whatever we're getting that from. And for as an example, we have Meraki, right? Cisco Meraki. As we go on a little more, I think, let me see. It just goes into a little bit here. Now you may, I think it's chapter 27. You're gonna have to go into to get a little more information about Meraki, Cisco Meraki, because you can actually be a Wi-Fi engineer, right? You can actually go down the deep dive of cloud-based architecture, or even wireless architectures, and you know, take that path, right? You can, even with this CCNA exam, you can literally just only do become a Cisco Meraki engineer, right? But I believe that's more information you get deep dive into the book. I'm just gonna go over, like I said, high level, so you guys can understand these terms. And then when you go into the flashcards, you can you know, again, remember these terms, because this is all about just comparing Cisco wireless architecture and mode. So you're just comparing. So on the exam, they're just going to say, what's the difference between, you know, autonomous and cloud-based, or give me an example of cloud-based or something in that sort. But I definitely want you guys to, if you're interested in cloud and wireless, definitely go into the book and, you know, go deep dive into Cisco Meraki, because it's definitely a high-paying skill out here. Okay, so yeah, so cloud-based AP architecture, right? It's just cloud networking service. You know, you configure on your APs, as you see down here. You're just configuring, you know, was device that you're using is the Meraki device, and you're configuring what you want. You're configuring the whatever details, whatever settings you have, and again, it's going to be managed via the internet. Another provider is going to manage that. And as you can see here, you have the cloud. That's management, and management literally manages your APs. Okay, that's all that means. So instead of autonomous, where they're gonna self-manage, you know, they're gonna self-contain, they're gonna do what they need to do by themselves. And, you know, you have your IPs that you can, you know, jump in each one and see, are you doing what you need to do, what I set you up to do? Right? Then you have your cloud-based, where you're in the cloud via the internet, via some type of GUI, and you are literally managing all of these via the internet. You know, so instead of, you know, actually hopping into the devices or the devices doing their own thing, we have, a cloud-based solution for that. And there are two like distinct paths of data when they're doing this cloud-based. And if I'm not mistaken, it's like a control plane and a data plane, right? So the control plane will like, it's used to like control and manage and monitor like the AP itself. And then you have the data plane, which end users, send traffic through the AP. So you'll have like a data plane down here, which could very well this represent, or maybe it just represents the radio frequencies, but we can say it represents the data plane down here. And then up here, you see this dotted line, and it's going up to the cloud. You could say this is the control plane, because this is the plane where, traffic management traffic is going. And this is the plane where end user traffic is going, right? That's usually how that's set up in a cloud based architecture, okay? Moving along to lightweight AP architectures. So we have a WLC, which is a wireless LAN controller, WLC. You definitely want to make sure that you understand this, as you're going to see it a lot on the exam. WLC, again, is just a wireless LAN controller, right? And is used to control the lightweight APs, the lightweight access points. And this lightweight access point actually has a protocol for itself to be able to communicate. And since it's lightweight, you see the name lightweight, is only for small companies, okay? So this controller uses a specific mechanism to talk to lightweight access points, wireless access points, so they can obviously switch traffic, right? Now, I believe the standard is still 802.11. I don't know if it could be like AD something, or it could still be 802.11 with wireless APs. I think why they call them lightweight is because they only perform that one task, which is like transmitting data through those frequencies, the 802.11. That's the only thing they do. They don't do anything else, right? They're lightweight. They're just means of, getting the wireless data transmitted from the client to the switch, to the network, right? And you can see that wireless controller is actually connected to the switch. So the switch can start doing intelligence. So yeah, the lightweight really doesn't perform anything but the basic standard, the basic 802.11 standard, which is their protocol of how they transmit data. And they use the protocol Lightweight Access Point Protocol, LWAPP, to communicate with the LAPs, with the lightweight access point, okay? So again, the lightweight is lightweight access points, a lightweight wireless access point, because it only does like a certain amount of data traffic. 802.11, that's all it does. As far as cloud-based, it can do more than that, right? We can actually configure and transmit stuff through the cloud, right? We can manage and do all those things. And as far as autonomous has its own mind. It does its own thing, right? It's self-contained, but as far as lightweight, it doesn't have that much intelligence, right? So it literally does small amounts of data transfer. And again, it's for small companies because it's lightweight. And you may see a company with a bunch of lightweight APs. It may just be like specific to that type of land, or they may have just, for some reason why they're using a bunch of these lightweight APs, because I've definitely seen them in my first contract at the hospital. I've seen the lightweight APs. I didn't work on them because I wasn't in the wireless department. I was more voice. So I didn't, get deep dive into it, but I definitely saw throughout network discovery that we had quite a few in the network. So that was pretty interesting. And then let's go in here. I think we talked about lag, link aggregation. I think that's more with the 802.3, something with Ether channel, something with Ethernet. Let's actually take a look here. lag link aggregation. What is link aggregation? Combine click the physical ports. Oh, yeah, it's just combining those ports. We did talk about that in Ether channel. That's why it looked familiar. I was like, didn't we just talk about that already? Yes, describe different various methods for using multiple parallel network connections. Okay, whatever. What else we got? Let's go to Cisco community. These are the best people you want to Google and get the article from. What is this? Oh, this is my Microsoft Edge. I don't really use this, but yeah, it says introduction, lag, link aggregation. Okay, of the WLC must match the width of the data pipe. We don't need that. I don't know what all that is. You cannot configure the controllers. Channel group. Oh, so yeah, it's about bundling ports. That's all that's all lag is. Okay. So it's just literally just bundling the ports. So when you see, hold on where I'm at. So when you see lag, you know that that's all about bundling ports. Okay. That's why that's here. So now we talked about autonomous, self-contained, do its own thing, have its own mind, very intelligent. We have cloud-based, which we manage, configure, and do all those things from the cloud. And then lightweight. Lightweight really only operates on the 802.11 standard. That's all it will do. And it will communicate with the WLC, which is a wireless LAN controller, right? Because you need even more intelligence to add to that. So we have a controller that will, we can control the lightweight AP with, okay? So then we have split MAC architecture, right? It's splitting functions between an AP and a WLC, okay? Now, autonomous APs, we know that they work alone. They have its own things. You configure them one by one and you let them go on about their business, right? Now, with that, well, with you allowing it to do it at once, it's kind of almost in a decentralized type of architecture, right? Because you configure what you want, and you allow it to learn the behavior. You'll allow it to do its own thing. Now, with doing that, it has some type of, drawbacks in your network. And that's where split MAC architecture comes in, because there's no like central point where you can like get things done. And we'll talk about QoS and stuff, but that's really a big factor with autonomous APs is the QoS. We want to be able to manage that QoS in some sense. So what basically came about is splitting functions between an AP, an access point, and a wireless LAN controller. And that is where split MAC architecture comes about, right? We're splitting the functions. We're moving some functions to like a central location, like the AP, and then we move some functions to the LAN, right? The wireless LAN controller. Okay, so we have some functions that we have like real-time and management functions. That's where the AP will handle. As you can see, the access point right here, you can see it will handle more of the real-time and management functions. That's where the AP is right here. And then you have the WLC. Let me blow this up. I don't know if you guys can see this, but I can't really see this like this. Okay, there we go. So AP, we have the real-time data and the management data will come in. Now we want to be able to split some of that up. So we have our WLC. Now, as you can see as well, we have our CAP WAP, right? Our CAP WAP, which is, again, it's really just a term for encapsulating data. And specifically is going to encapsulate data between an AP and a wireless LAN controller. Okay, that's, again, it's split MAC. So we're splitting up the functions of the architecture. We have real-time traffic, meaning that, users are coming in, users are accessing the network through, like you can see here, their SSID, they're putting in their password, they're sending emails, sending chats, whatever end users do. Okay, and the AP is going to get that automatically. Now the AP, that's all it cares about. But then we have the wireless controller. The wireless controller shouldn't care about the access, who's trying to access it and switching that forefront data. The wireless LAN controller should do what? Should control. So we want to give that, we want to have that operate on only like the management side, only the configuring side, only management, right? Security, QoS. Again, we'll get into QoS. We haven't got there, but this is really what it was really made for, is to help with QoS, help with quality of service. So we can ensure that our data is getting where it needs to get, because audio will trumps, getting, getting on a website, surfing the web. And if I was going to talk over the phone and surf the web, my, internet on the web, my web page may not load, but I'll still be able to talk freely. It may be a little, buffer, a little jitter here and there, but I'll still be, my call won't end. So that's QoS. QoS is prioritizing this data. Who should get the data first? What type of data should get to where it needs to get first? Because all this data is coming. So with split MAC, we have separation of the two. Okay, so the AP is going to do one thing, which is real time, and the wireless controller is going to do the other thing, which is what admins do, right? Which is what is management do, what is the authentication or security. Again, QoS is the biggest thing, and they're going to speak between each other, right? And as you can see here, they're speaking between each other, and they're using a certain protocol. And that protocol, let me see. What does this stand for? It's like control and provisioning of something wireless, control and something. I don't know. The control and provisioning of wireless access points. So yeah, I knew that. Standard network protocol. Okay, cool. So yes, and it manages the collection of wireless data points known as wireless. Let me go in a little more. Let's see what else. Soft Cisco controller. Cap WAP, I don't know, however you want to say that. Let's see, what did it say? It says you can manage the APs with the WLC, but it has many features. Communicate at all times. Okay, they're just saying what they need to say. A controller-based solution indeed essentially manages the configuration for all access points that has joined the WLC. It will also manage the firmware. Okay, so it's just basically, let me go up here. If you need to deploy a wireless network, you have two options. Use an autonomous AP or lightweight AP. What's the difference? Okay, they're just telling you what's happening. If you use a lightweight AP, you need a central device to manage the AP in your network. The device is called a wireless LAN controller. The AP uses a protocol called CAP WAP before LA. Okay, you won't have to look in the book. Okay, so basically, yes, it's, let me go back here. It's basically just a tunnel for the AP and the WLC to communicate with each other. That's all, right? Because the WLC needs to be like, hey, AP, I need you to do this, and what's happening with here. And then the AP will connect to the WLC and say, hey, well, this user is trying to access with this password and this SSID. Is this right? And then the WLC will probably say, well, no, it's not right. So deny this user, or it is right. So let this user through, so that's kind of how they'll talk between each other. They'll do like a check and balance type ordeal. Okay. So those are the architectures. Pretty simple, right? We have autonomous, does its own thing. Okay. Cloud-based is managed and configured via the cloud, via the internet, not on its actual device to let us do what it wants to do. Lightweight AP, it will only operate 802.11 standard. It's very simple, and it communicates with a WLC, a wireless LAN controller. So then when you have your AP and your wireless LAN controller, you can have a split MAC architecture. So you can split up the operations. You can have the AP deal with real-time traffic, and then the WLC does like some type of checks and balances to check whatever the AP has going on, and they can communicate through a protocol called control and provisioning of wireless access points. It's a tunneling protocol. And again, all you really need to know is it caps all data between AP and WLC, right? That's really the definition you just need to worry about with that protocol. Okay. Now modes we have for AP, for a wireless access point, and it's in I believe it's just lightweight. Let me see. Yes. So, because autonomous, you do it at once, and then cloud-based, you have something else. So so with lightweight, you have a lightweight AP, you can put it in these modes here. We have local mode, which is a default mode. You might want to write that down. Local mode is a default mode. And it offers the network ID when it's not transmitting, some things in that. You might want to look into the book and actually read up on these modes. But just briefly, local mode is the default mode. You should really know that. And then monitor mode, the AP is just acting as like a monitor, right? It's just monitoring the network. It's a dedicated monitor. You can have the AP go into flex connect mode, which means that you can kind of, I believe it can do both with the WLC, and instead of having like split architecture, it does both, right? So in case the WLC go down, it will act as a WC as well, as a WLC, yeah, as a wireless LAN controller. So that's flex connect mode. You have sniffer. You can put your wireless access point in a sniffer mode, which means that it will sniff out packets. So you can kind of use it as like you in the field, you may hear something like Wireshark, and Wireshark is like a packet capture type software to where you can capture packets and decode them and see what's going on in the network to see if if some data was corrupted or if data is being sent and where is it failing, if it is failing somewhere. So it's just, again, it's just basically, you're just analyzing packets. So that's what a sniffer mode is, an analyze packets. You have the rogue detector mode. You can set that in. Rogue detector is like, rogue means like malicious. So you can set this AP to be in some type of like, detects malicious APs or malicious devices that's trying to connect to the wireless network, right? So this lightweight AP, you can say, hey, it's on the network just to detect malicious hosts in devices or any devices on the network, right? So that's one mode you can put it in. You can put it in a bridge mode. Bridge, of course, what it is bridge is to link two locations together. So maybe if you have like 3 access points, maybe the middle one acts as a bridge and not more where you can connect to, but something where it bridges the other 2 access points together in some sense. And then you got the flex plus bridge mode, right? So, you got the flex connect and you can bridge it together. So it could be like a default for like redundancy with the flex, and then bridge where it's bridging the data. So you can put it in both those modes together. And then SE connect mode, and that's something that you have to use some type of special software. I think SE means like expert software, something like that. And you need a software for that. We don't use that. I haven't heard that outside of this exam. So forget that. But these are the modes. And I believe we are in chapter like 27, 25 with wireless. And honestly, you can just literally just like copy local mode and put it in the search when you get into the book and look where local mode is at. So you can kind of go a little more deep into these modes, okay? And just so you can know as well the difference, because they will ask you the different modes. Like, so what, if I was to set, if you were a network administrator and you set a lightweight AP as sniffer mode, what would the AP be doing? Like, what is the primary functions of the AP? And then they'll give you a list of things and one will be what sniffers do. So it's good to really know, like, okay, local, obviously that's the default mode of a wireless access point. But then we have monitor. What does monitor mean? It means I'm monitoring something. Flex connect, that means I'm flexible in how I connect. How do you connect? And of course, you might have to go a little more deeper into that, but you just flex connect with the split architect mode. Sniffer, again, I'm sniffing packets, I'm analyzing packets. Rogue detector, I am looking at, detecting malicious devices. Bridge mode, what is a bridge? I'm, from one to the other. So that's what I'm trying to do. I'm trying to bridge data from one to the other. And then you got flex plus bridge. So as long as you know what flex is, you know what bridge is, you know what both of them are. And then SC Connect, again, I think that's something like software. Let's just look really quick before I start giving out. SC Connect mode AP. What is that? SE Connect mode AP. SE Connect mode is different. It's used to AC will listen. They don't really want to tell me. Let me go here. I mean, I guess I could just click the top just to get a little. Oh, here we go. The SE mode allows you to connect the LAP using Cisco Spectrum Expert. Oh, that's what it is. Well, Spectrum Expert is the software, and gather vital information about the radio frequency spectrum surrounding the lab, right? Do mind to keep the lab operating in SE Connect mode, will not be broadcasting any SSID, and does service outline clients. The mode is strictly used for troubleshooting purposes. So if you ever get the question on SC Connect as far as the mode, at least you know that, hey, I'm only going to put it in this mode to troubleshoot. Okay. So yeah, I suggest you definitely go over your modes. Again, I think that's chapter 27, 26, but you can easily just Google. I mean, not Google, but just do the search right here, the little search. So yeah, that is compare Cisco wireless architecture and AP modes. So we know the different architectures, and then we know the modes. Okay. Let's move it along. Let me make sure. Yep. This is next. Now, before we even go into 2.7 through 2.9, which is pretty simple, right? It's pretty easy. Do you guys have any questions, comments, concerns about anything that we talked about? Anything from yesterday or anything? No? Okay, that's fine. We can move it along. Let me make sure I have this up here. All right, so this is the last three sections, right? 2.7, which is about let's just go in. 2.7, that's describe physical infrastructure connections of a wireless LAN components. Right, so we have AP, wireless, WLC, wireless LAN controller, access, trunk ports, and lag, which we low-key kind of talked about already, right? So AP, what is an AP? You can see down here. Nobody, okay. You can see down here an AP, it's an access point. We can have autonomous, we can have something in the cloud, we can have a light. Okay, it's where our wireless device is going to broadcast frequencies that we can actually hop on, right? And we can actually start to get into the network, like pretty simple. And then our wireless LAN controller here at the top is where we control our wireless LAN. Okay, we control our APs, we control what's happening with our wireless APs and configure them and tell them what's going on and do checks and balances, all that good stuff. And as you can see, we have our tunneling protocol, where it encrypts the data from our APs, from our lightweight APs to our controller, okay? And then we already talked about access and trunk ports. We have, you see, one is trunk, one is access. Trunk link carries multiple VLANs. An access link is only for one VLAN. So we kind of already know that, right? That's kind of what we've already been talking about as far as VLANs are concerned. Let me come down. And just really quick, this is what you would use, this is the knowledge you would have, when you're tasked to build a wireless LAN, right? You get your APs, right? Do you want autonomous? You want a lightweight? What do you want? And if the course of is lightweight, you're going to couple it with a WLC, a wireless LAN controller, and you're just going to make sure that everything is connected. Okay. And that's where the access and the trunk ports come in at. All right. So that was pretty simple. Describe the physical infrastructure. That's the physical infrastructure right there. Now, going in talking about lag brings us in 2.7. Describe physical infrastructure outside AP, but it goes into lag, right? And then we can go into physical ports and logical interfaces, which we've been talking about. So lag is the link aggregation. I believe the G is just the group when they added link aggregation. Basically, again, multiple interfaces connected in a single link. We've already discussed, we already searched what lag is right here. Lag. We can just see a link aggregation. We don't have to, we could say group. Lag combines multiple physical links into a single logical interface, which is referred to as a bundle interface, right? So that's really all it is. It's bundled interfaces. When you see lag, just think of bundled interfaces. Let me come here. One moment. Oh, that was me clicking that. Okay. I need a new mouse for real. Okay, so we talked about link aggregation. It's just multiple Ethernet connections in a single link. Okay. Now it acts as though like ether channels. You can kind of say like, oh, okay, you know, lag is the same thing as ether channel, but you know, the WLCs doesn't support like negotiation protocols. You can call ether channels like a negotiation protocol. So like LACP or the Cisco proprietary port aggregation, it doesn't support that. So they're always going to use lag instead of, you know, what we will look at it as, which will act as the same as ether channel. Okay. Lag just means that we are bundling multiple interfaces, multiple links into one link, but that doesn't mean that we are configuring ether channel. So I just hope that you guys can decipher that, right? It's lag, but it is not ether channel, even though they operate the same. It's just Cisco LAN controllers, they don't support link aggregation as far as negotiation is concerned. So they don't negotiate anything. We're just bundling or we're not going to bundle. Okay. So it's either nothing or it's on. Okay. So just like the, you know, the VLANs, you know, the wireless LAN can be, you know, segregated, and it can be segregated. I believe the max is 500 wireless LANs could be configured on this console, on this wireless LAN controller, but only so many could be active. Let me see. Let's Google that. How many? Because they act as just like VLANs can be configured. I'm gonna say configured on WLC. Hopefully I said that right. Can now control up to 512 wireless LANs. So one wireless LAN controller can control up to 512 wireless LANs. So that's just the equivalent of saying that a switch can control 512 VLANs, right? For lightweight access points, though, for lightweight APs. So yeah. Let's see. But I think that you can only have so many active, though. That was something that I read. I think you guys should read that in the book, because even though you can configure 512, only so many could be active. And if I'm not mistaken, it's like 15 or 16. Oh, here we go. That's the number I'm looking for, 15 or 16. Because I had this on my exam. And I knew I got it wrong because I'm just like, I don't know. I didn't read this. I didn't read this part of the book. Well, I did, but I don't know. I didn't go hard on wireless that I thought I should, but I honestly didn't care too much. And I saw this and I didn't care to put it in my head. And this was the answer. And I knew I got it wrong somehow. Let me see. There we go. So each wireless LAN has a separate wireless LAN ID, a separate profile name, and a wireless LAN SSID. All access points can advertise up to 16 wireless LANs. Okay. However, you can create up to LANs and then separately advertise them. So yeah, I think you should go into the book and go read a little more on this as far as how many you can configure. We kind of went down a little rabbit hole here, but how many you can configure on the wireless LAN, because that was a question for me. I saw that and I would say I'll never forget that question again. So definitely make sure you, again, it's chapter 27, 26. But yes, now let's see, we have the physical ports, right? Physical ports and logical interfaces. What are physical ports? They're actually in the back of the AP is, with the Ethernet cable, that's physical, something you could touch, something you can plug into. And then what is logical? Logical means that it is not real. It is not physical in a physical sense. It is something that is created by software, almost in a virtual sense. Actually, I wouldn't say it's created by software, but it is in a logical sense, in a theory sense, in a sense that, we like data to flow, but it's not how data is physically flowing. Okay, so make sure you understand between logical and physical. Okay, there are two different things. One you can touch, one you cannot touch. And let's see down here. Let me look into this. What did they say? VLAN. Okay, so it's just basically telling you about the interfaces, how the interfaces can be dynamic. You have a VLAN for management, and you have your wireless LAN, which is going to advertise that SSID for that VLAN. And it also shows, what's happening through the wireless controller. The switch, you are setting up VLANs. The wireless controller, you're saying, hey, you're setting it up actually. Is this wireless LAN, whatever this number is, whatever that number is, and they'll all have their own SSIDs, they'll all have their own network IDs, and which will be, broadcasted through to the API to the AP, which is to its end devices, right? That's how we get on our Wi-Fi. So just showing you here a little more, kind of what we already saw in the previous 2.6. So that's pretty regular here. All right, now 2.8. Let me just really quick see if they talked about management too much. I don't think as far as management interfaces down here, but I don't think you have to learn too much about it in the book. Like I said, they may talk about the management interface being used for like normal management traffic, where we, manage our network, such as authenticating users, or we're talking to other wireless LAN controllers, or even going in using other protocols like, SSH or simple network mail protocol, or, certain protocols that's used for us as network engineers to manage the network, which we'll start to get in more because you'll start to see more and more protocols that we use to manage, because we're not there under security. I think that's what we'll learn, how the protocols to manage. Well, here's some protocols here, right? So describe AP and wireless management access connections. Telnet, SSH, HTTP, HTTPS, console, and TACACS plus, and radius, right? These are terms you definitely want to ensure that you know, okay? Obviously, when we go into our our switch, we want to remote in into our access points. We are going to set up a way to remote in, which is Telnet and SSH. As you know, Telnet is not secure. It's 23, it uses UDP, and we don't want that. We would rather use SSH, which uses 22, and it's much secure, uses TCP. It needs a handshake to say, hey, are you the one I want to send data to? Yes, I'm the one you want to send data to. And then, okay, I'm about to send some data to you. like a three-way shape. And as you can see right here, this is our PuTTY, which we talked about earlier. And it's using SSH, and you put in the host name, the IP, which is the management IP address. You're going to put that IP address in, make sure the port's 22 there, click open, and it's going to open the CLI line of the device you want to access, because it accessed the IP address, right? We'll get into that. No fret. I mean, we've kind of already been doing that. We're going into the CLI. It's just we don't use PuTTY, and this is all it is. You just open it. It opens just like this. You put in your IP. You put in what connection you want to have, and you just say open, and it literally remotes you into whatever IP address you want to remote into. Okay. Obviously, you're gonna have to. That's why we set up line console login. We set up secret. We set up exec mode passwords. We set up things to where, because anybody can remote in, but do you have the necessary credentials? So that's why we have the message of the day to say, beware, don't access unless you have, permission, and then you set up your permissions. Okay. HTTP, right? That's the initial setup. So when you are initially setting up your wireless LAN controller, you're going to initially set it up using HTTP, which is hypertext something protocol, hypertext something, or is it HTTP? Let's see, hypertext transfer. That's what the T was. Hypertext transfer protocol. Okay. That's how you're going to initially set up your wireless LAN controller, right? Obviously, we know HTTP. What is that? It's like a web address, or www, whatever, www. But you're going to use HTTP colon, // and then the IP address, right? It wouldn't be an actual like domain name. And then you have your HTTPS, which is the Hypertext Transfer Protocol Secure. So that's when you actually go in and start, securing. So once you initially set up your WLC, you have to use, obviously just regular HTTP. But once you get in, you set everything up, you set your passwords, your username, and whatever the case may be. Now you use the secure part. And as a new person, you're going to come into a network that already has it secure. So you don't have to worry about going through that whole spiel of it only having to be HTTP. But it's good to know because, hey, what if you get thrown out there to be an architect? So you definitely want to know this is how you set it up first, and then you start using it with that. No fret, we'll go through a lab. And then we have console. We already know what console is, right? It's console cable, rollover cable, where it's going to plug directly into the wireless controller. Now, that's really not what we do out here because we're all about remote work. But you may be so awesome that the company flies you out to the headquarters or to one of their data centers, wherever the data centers could be. The data center could be in Chile. The data center can be in Paris. Who knows? But they'll fly you out there and say you need to connect to you need to console in and see what's going on. And you fly out there. You got secret access. So you go down. Usually it's in some type of basement or something, and you will connect. You'll have your rollover cable connected to your computer and then connect the other end to the wireless LAN controller, and you will get into the CLI line like that, right? And then we have TAC-ACS plus / radius. We will talk more about this. This is a security protocol. So when we get to the security section, we will go in and configure all these. Maybe we'll configure it. I don't know. But TAC-ACS Plus is a Cisco security protocol, and Radius is an open source protocol. All it is it allows a host device to be authenticated against a remote server. Or locally authenticated on the device. So when you are, let's say you want to, I don't know, get into let's just make it simple, get into the switch, and the switch asks you for a username and password. What you do is TAC-ACS, if it's configured, TAC-ACS will take your username and password, send it to a remote server that's only dedicated for authentication, and say, hey, server, I have this username and password. Are they supposed to get in here? And the server will say, let me check my database. Yeah, they can come in here, or no, they can't. And then they'll send that message to your screen, and your screen will say access not, login wrong, or it'll just take you to the next screen because your login was successful. Okay, that's all TACACS/Radius is. One is open source, the other one is Cisco. TACACS is Cisco. I don't know what TACACS, I think it's like terminal access control something. Let's take a look, because that's something you're gonna need to know. TACACS plus versus Radius. Let's just do that. TACACS plus uses TCP, therefore more reliable than Radius. Okay, but they want you to use TACACS. Let's go here. I think they should give us the full definition. Yep, terminal access controller access control system. Isn't that a mouthful? So TACACS is a lot. You should know what it is. Terminal access controller access control system is a Cisco proprietary protocol that is used for the communication of Cisco client and Cisco ASIC server. It is used TCP. Okay, so it makes it reliable. Basically, they're just saying that it's used for the security server. And then Radius is remote access dial-in user server service. It is an open standard protocol used for the communication between a vendor AAA client, which is like AAA means authentication, accounting, and something else. It's basically, again, it's just checking authentication, accounting, and something. I don't know the other
Authorization, right?
Authorization, yes, thank you. Thank you, yes, authorization. So yeah, it's there to, again, just check your credentials. It's just checking to ensure you can perform the task you are meant to perform. Because as engineers or as IT administrators, we set permissions for people. So some people are just guests. Some people are just regular employees. Some people get management. Some people get executive privileges. Some people just get read-only privileges. Some people get read-write. Some people, you know what I'm saying? Like, it's so many different types of privileges. We have a whole server dedicated, and that's TACACS or Radius. Okay, so we'll get more into that, but just know that that is a management wireless LAN controller management connection that we can use. Okay, so these are very good terms to know even outside of wireless, because Telnet and SSH, I mean, that's outside of wireless. That's just how we get into the CLI, just like the console. That's how we get into the CLI. HTTP, that's specific to wireless LAN controller because that's how we set it up. That's the initial setup. We use this one time and one time only when we're first taking that baby out the box and setting it up. Outside of that, we continue using HTTPS to get into the wireless LAN controller and click on what we want to click on. Okay. And of course, the last thing is configure the components of a wireless LAN access for client connectivity using the GUI only, the graphic user interface only, right? So let me look at here. Here's the lab we will use. And you can go ahead and do this tonight, or you can wait till tomorrow, because tomorrow will just only be about this lab. But you can do this tonight if you want, like I said. But yes, we'll be doing this as far as connecting a lightweight access point and then a wireless LAN controller, and our laptop will connect wirelessly, and we will set up the GUI. Okay, we'll see we have these IP addresses. And when I say the GUI, like I said, it'll look like something like click here, click there, you know, set up here. It'll be really, really good with the user interface. It won't be a CLI. It'll be, like I said, a website that we'll go to. And that's how you set up your wireless LAN. Okay, let me see if this is in here. Let's see if this is in here. Labs. Yep. So yes, if you want, you can go ahead and take a stab at it, or, you know, I would suggest just brushing up on your terms, ensuring that you know what is going on. And you can go all the way back from day one, or you can literally start with just 2.6 with knowing the architectures. So autonomous, cloud-based, lightweight, make sure you know what those words mean. And then we go into our infrastructure. We know what AP means. We know what WLC means, access and trunk ports. We know what those are. We know what lag means. We know the difference between physical ports and logical interfaces. Okay. We understand telnet and SSH. We understand console, TAC-AX, and plus and radius, and then console. Okay. Definitely going back to day one. definitely. So use tonight, or you can use tomorrow to really just go through all of what you've been through right now. I was going to create like this final midterm for you guys to go over these 2 weeks, but let's do the midterm after week 3 because we have 6 weeks. So after week 3, you guys should have all the basic knowledge of what is a network, what a network consists of, what's layer 2 protocols, and what are layer 3 protocols. Right there, that's how data travels through the network. We'll put it all together so it'll all make sense, and really it's just terms for you to remember after all of that. Okay, and then we'll have a midterm so you guys can test where your knowledge is and see what you need to do, because everything after week 3 is really just extra knowledge, honestly. If you don't understand the first 3 weeks, then there's no point of going on 4, 5, and 6. There's just no point to secure something that you don't even know how to configure, right? Why would I secure a network if you don't know how to configure the network? If you can't even get the host name and put the passwords and do all these other things, why are we adding any other protocol? So it's all good. Next week will all be about end-to-end connectivity, ensuring that we can use the ping feature, right? Which means that, hey, I want to talk to a computer, and the computer's going to say, hey, you could talk to me. That's all will week 3 be about. All right. So yeah, tomorrow we'll do some configuring. But outside of that, yes. Do you guys have any questions, comments, concerns? Anything at all want to talk about? This was pretty simple, pretty straight to the point lesson. We're just describing, so we're just writing down definitions and terms and memorizing those. That's really it. So that's really all I can say is you really have to just memorize things. You may not, again, fully understand, but that's where the flashcards come in at. That's a lot of times what they do overseas. Not saying that that's what we should do, but overseas, they literally will memorize different versions of the test, and then they will go and take the test because they have memorized the different types of questions and answers, and they just play the game of memory. And that's how a lot of overseas get their certs, believe it or not.
I would add this, if you could, before the midterm, like 2 days to go over everything before the midterm. You know what I'm saying?
You said before the midterm, 2 days, go over everything?
Give us like 2 days and we just go back from day 1.
Yeah, but you may have an overload. I mean, it's up to you if that's how you want to study. If you want to go through everything and then 2 days before you just do like a brain dump of just like everything. Honestly, like 3-4 days before my exam, I didn't even look at anything because I was just so tired of just studying, and everything was just making me sick. I didn't want to look at a protocol or nothing. So for 2 days, I just chilled. And
that's what I'm talking about, like before we take the midterm and the end of the course, like, because every day we come in here, we're getting a little bit more new information. Like, I'm saying 2 days to let all that marinate, and then we go, just refresh.
Oh, for sure. Yeah. So, you do this step every day, you get a little more information. And then I would say, like, you would schedule your exam. And I would probably say, like, a week before your exam, you're probably just really banging out flashcards, banging out terms. Because you already, you've been getting fed the information little by little. So you know it. It's just, how does it retain? How does it stay? Because on the exam, you can't have anything. You can't have your phone, nothing. Somebody's looking at you the whole time. So flashcards, bang it out there. And then, I would say, like I said, every day, as long as you dedicate at least an hour every day. You should be good to go, honestly, because it's all memorizing. But you want to do more. You want to do a good 2-3 hours every day, even if those 2-3 hours only consist of flashcards or only lab or only reading. That's okay. Or only transferring notes. That's okay. It's the fact that you are doing it every day, and trust you will prevail. Okay. It's all about skill. It's all about your will, not your skill. Okay. Who cares how skillful you are in this? It's about your willingness to succeed. So hopefully that helped you guys out a little bit. But yeah, today's Friday. Tomorrow is lab. Sunday we won't be doing anything but studying. So you don't have to come to the classes tomorrow. It's up to you, because again, we're just labbing it out. But you definitely want to make sure that you are utilizing this time to review everything that you don't know, because next week we're just about to pile on more information. You can think of it as we're going into year 2. You're going into your bachelor's year. So yeah, that's it. So if no one has anything else, then maybe yes, ma'am. Oh, you're very welcome, very welcome. So yeah, if no one else has anything else, then we can be out. See y'all tomorrow or Monday.
Good night, everyone.
Good night. Let me stop sharing. And then how do I stop the recording?